Welcome to New Findings of the Universe. For generations, humans have been fascinated by the possibility that we are not alone. From ancient myths to modern UFO stories, the idea of life beyond Earth has captured our imagination. But today, this question is no longer driven only by speculation. It is driven by data. Scientists are now studying what may be the strongest evidence yet that life could exist on a planet far beyond our solar system. That planet is known as K218b, and it is located 124 light-years away from Earth. That distance is so vast that the light we see today left that planet more than a century ago. And yet, using one of the most powerful scientific tools ever created, astronomers are beginning to analyze what is happening there right now. What makes this discovery so compelling is not a photograph or a signal, but chemistry. Researchers studying the atmosphere of this distant world have detected molecules that, on Earth, are closely associated with living organisms, especially life that exists in oceans. These molecules are not proof of life, but they are a powerful hint, one that scientists take very seriously. This is not a story about aliens landing or civilizations sending messages. This is a story about how light traveling across space can carry information about biology. It is a story about how careful measurements and patience may bring us closer than ever to answering one of the oldest questions humanity has ever asked. Could this distant planet truly be home to life? And if it is, what would that mean for our understanding of the universe? Stay with us as we explore the science behind this discovery. And if you want to continue exploring the deepest mysteries of space, subscribe now to New Findings of the Universe. K218b is not a planet like Earth in the way most people imagine. It is larger, about 2.5 times the size of our planet, and it orbits a small red star. Scientists believe it may be what is called a water world, a planet covered by a vast global ocean beneath a thick atmosphere rich in hydrogen. This type of planet expands our idea of where life might exist. For a long time, scientists searched only for Earth-like worlds, rocky planets with thin atmospheres and familiar conditions. But the universe does not follow our expectations. Life may find a way in environments that look very different from our own. What makes K218b especially interesting is its location. It orbits its star at a distance where temperatures could allow liquid water to exist, depending on the atmosphere. Liquid water is important because, as far as we know, life requires it. But water alone is not enough. The chemistry of the atmosphere matters just as much. This is where the James Webb Space Telescope comes in. Unlike earlier telescopes, Webb can analyze the composition of a planet's atmosphere by studying how starlight changes as it passes through it. Every molecule absorbs light in a unique way, leaving behind a chemical fingerprint. When scientists examined the data from K218b, they found signs of molecules that raised immediate attention. On Earth, these molecules are produced almost exclusively by living organisms, particularly tiny marine life. Seeing them on another world immediately raises profound questions. But science moves carefully. These findings are exciting, but they are not final. They are signals that invite deeper investigation, and that investigation is now underway. The molecules detected in the atmosphere of K218b are known to scientists because of their biological role on Earth. Here, they are linked to life in the oceans, produced by microorganisms that play a major role in our planet's ecosystems. Because of this, these molecules are often discussed as potential signs of life when searching beyond Earth. However, finding a molecule is not the same as finding life. Nature is creative, and the universe is full of environments we do not yet fully understand. Scientists must consider whether these molecules could be produced by non-biological processes under alien conditions. This is why researchers emphasize caution. Even with strong signals, it is possible that unknown chemical reactions, driven by heat, pressure, or radiation, could create similar results. The universe has surprised us many times before, and it will do so again. What makes this discovery stand out is not certainty, but strength. The signal detected is stronger than any previous hint of similar molecules on an exoplanet. And scientists involved in the research believe that with more data, they may be able to confirm whether these molecules are truly present within the next 1 or 2 years. If that confirmation happens, it would not mean instant proof of life, but it would move the discussion from possibility to probability, and that shift would be historic. This careful approach is what separates science from speculation. Excitement drives discovery, but skepticism protects truth. Both are essential, and both are shaping the conversation around K218b right now. What makes this moment remarkable is how it demonstrates the power of modern astronomy. The James Webb Space Telescope is capable of analyzing the atmosphere of a planet hundreds of trillions of miles away using only a faint trace of light. That achievement alone is extraordinary. Think about what that means. From Earth, scientists can detect changes in starlight caused by gases surrounding a planet that no human will ever visit. This is not science fiction. This is precision measurement at the edge of what technology allows. Yet, even with such advanced tools, uncertainty remains. Data must be interpreted through models, and models depend on assumptions. That is why the scientific community debates these findings openly. Some researchers believe the data strongly supports the presence of these molecules. Others argue that the signal could be explained in different ways. This disagreement is not a weakness. It is the process working as intended. Through debate, testing, and repeated observation, weak explanations are eliminated and stronger ones remain. The next steps involve gathering more light from K218b, refining atmospheric models, and searching for additional chemical signatures that would strengthen the biological interpretation. Science does not deliver answers in dramatic moments. It delivers them through accumulation. If life does exist on this planet, it will not be confirmed by one study or one headline. It will be confirmed when evidence becomes overwhelming. The implications of such a discovery would be enormous. If life exists on K218b, it would suggest that life emerges relatively easily under the right conditions. That would mean life may be common throughout the galaxy, even if intelligent civilizations are rare. Right now, Earth is our only known example of life. With a sample size of 1, it is impossible to know whether life is rare or abundant in the universe. A second example, even microbial, would change everything. It would influence where we search next. It would shape future telescope designs. It would redefine our understanding of biology as a cosmic phenomenon, not a uniquely earthbound one. But it is important to separate excitement from exaggeration. This discovery does not mean aliens have been found. It does not mean another Earth has been discovered. It means that science has identified a promising target, one worthy of intense study. And that alone is remarkable. Some scientists also remind us that life may not be easiest to find on distant exoplanets, but closer to home. The icy moons of Jupiter and Saturn, with their subsurface oceans, may offer more accessible environments where life could exist. Spacecraft are already on their way to study these worlds, searching for chemical signs beneath frozen crusts. The search for life is happening on many fronts at once, using different tools and strategies. K218b represents one path, one possibility among many. But it is a powerful reminder of how far our capabilities have come. Only a few decades ago, we did not even know exoplanets existed. Now we are analyzing their atmospheres. The question of whether we are alone has been asked for thousands of years. For the first time, we are developing the tools that might actually answer it. The discovery surrounding K218b should be understood as a moment in a long journey, not a final destination. Science advances through patience, not leaps of belief. Every new observation refines our understanding. Every debate sharpens our conclusions, and every unanswered question pushes us to look deeper. Whether life is eventually confirmed on this planet or ruled out, The process itself is valuable. It teaches us how planets evolve, how atmospheres behave, and how life might arise under conditions very different from our own. The universe is vast, ancient, and full of surprises. And we are only beginning to learn how to read its signals. So are we alone in the universe? For now, the honest answer remains the same. We do not know. But for the first time in human history, we are no longer asking that question in the dark. We are gathering evidence. We are testing hypotheses. We are listening carefully to the light of distant worlds. K218b may or may not host life, but it has already done something extraordinary. It has brought us closer to an answer than ever before. If you want to keep following these discoveries as they unfold, if you want to understand not just the headlines, but the science behind them, subscribe now to New Findings of the Universe. The universe is speaking, and we are finally learning how to listen.